Hello and welcome back. For this video we're going to show how to work with some operations on radicals. Alright, so here's our first example. We have 4 square root of 10 plus the square root of 13 minus 9 square root of 10. Now one of the key things you need to be aware of when doing adding or subtracting with radicals is you need to treat the radical as if it were a variable. So one way of thinking of this right here would be like 4b plus c minus 9b, where the b's represent the square roots of 10 and the c represents the square root of 13. Well, these end up being like terms, this one here and this one here, so it's like saying 4 minus 9 times b. We're going to do the same thing down here, so 4 minus 9 is going to give us negative 5. And then since this up here would end up being negative 5b, so the b just comes along for the ride, the square root of 10 comes along for the ride. So you have to have like radical parts before you can add or subtract. Now since this one has a square root of 13 and this one has a square root of 10, these can't be combined together in any way, so I just add the square root of 13 on to the very end. And this right here becomes my simplified answer by adding and subtracting. For our next example, we have 5 square root of 3 plus the square root of 48. Now the way it's written, it looks like they're not like terms. However, square root of 48 is not completely simplified. So what you'll want to do is find the largest perfect square factor that divides into 48, and it turns out that that is the square root of 16. 16 goes into 48 times 3. So square root of 16 times 3 is still square root of 48. And of course the square root of 16 comes down as 4 times the square root of 3. Now you bring down the rest of your problem. You had a plus and you had a 5 times the square root of 3. Now since these have a common 3 under the radical, you can actually take the 5 and the 4 out in front, which are the rational components, and add them together. So 5 plus the 4 will give you 9 square root of 3. Notice we didn't do anything with the 3, we just left it under there. It's like saying 5n plus 4n is going to equal 9n. We didn't do anything with the n comes along for the ride, so we didn't do anything with the square root of 3, it just comes along for the ride. For our next example, we're going to do a multiplication with the radicals. So we have a radical on the outside, and it's going to be distributed to both of these terms inside. Now the number out in front of this radical is actually a 1, so we treat that like a 1. So when we do 1 square root of 5 times 4, it's really 1 times 4, which is 4. And the square root of 5 comes along for the ride because there's no radical component attached here to multiply with a 5. So it's just 4 square root of 5. And now we're going to take this square root of 5 and times it by a negative square root of 20, which is going to give us negative. Now 20 times 5 is going to be square root of 100. Since these are both underneath the radical, you can multiply them together. However, you can't multiply stuff outside with stuff inside, so that's a no-no there. Now if this right here under the radical or this right here can be simplified further, you should take it a little bit further. And it turns out that 100 is a perfect square, so this can be rewritten again as 4 square root of 5 minus, and of course the square root of 100 is just 10, and this here ends up being our simplified answer. For our last example here, we have a binomial times with another binomial. And the way we're going to do that is we're going to take this first one, which is square root of 7, and we're going to distribute it to the first number. So square root of 7 times square root of 7 is the square root of 49. And we're going to distribute it to the second number over here. So square root of 7 times negative 3 square root of 2. Remember there's a 1 out in front, so we have 1 times the negative 3 is going to give you negative 3. And the square root of 7 times the square root of 2 is going to give you the square root of 14. Then we're going to go back to this second term and distribute it to the first term here. So square root of 2 times square root of 7 is going to give you a positive square root of 14. And square root of 2 times negative 3 square root of 2. Now there's a 1 out in front, so 1 times negative 3 is negative 3. And square root of 2 times square root of 2 is the square root of 4. The only thing we have left to do is simplify. Square root of 49 is going to come out to just 7. These two are like terms. So there's a 1 right here. So this is negative 3 plus 1, which is going to give us negative 2 square root of 14. Now remember, you don't do anything with these. They come along for the ride, but they have to be alike in order for you to do a calculation here and here. And over here we have negative 3 times, because the square root of 4 is just 2. And now we can simplify this part a little bit further. 7 minus 2 square root of 14. Well, negative 3 times 2 is negative 6. And it turns out that these two parts right here are rational components. So if I get rid of the middle, it's like saying 7 minus 6. Well, 7 minus 6 is 1. And I still have a negative 2 square root of 14 left over. And this ends up being our final simplified answer.